Good. Good job. Good job. All right. Since you're amazing, ladies and gentlemen, do these 3 questions. Yes. I am not. I have things going on this weekend. So.
I'm going to the play on Friday. Are you in the play? No, I quit the play.
I'm glad to see you guys finally picked the play that has some scientific significance.
Oh, what do you mean? Pups had science.
Yeah, okay, we'll go with that. Let's go. 10 minutes to do these 3 problems. Let's go, let's go, let's go.
We're learning about science and math.
Rocio.
And we're like, hey, this isn't good. And
We're like,
hey, this isn't good. No, it's bad. I thought we were doing
oh, we're doing that.
So, I watched a movie on it. Yeah, not just movies. Back to work. Oh, there's that.
Okay.
It was a charge for aluminum. Plus 3.
Please remember, molarity equals moles per liter, ladies and gentlemen. Molarity equals moles per liter.
Yeah, but the 3 is in with the CO. So it'd be AlCO3 parentheses 3. No, there's still a 3 in with the CO though. Because you see, no, they don't control because it's a 3, a ternary. Oh, and carbonate is 2 so it'd be Al2CO3.
What is carbonate? Oh, go back. Like this is CO3. Wait, CO3 charges. Yeah. So
Find the mass and put the mass in the
So 3. Polymer has a thermometer, right?
We have to find, yes, we have to find the moles that are in the formula and then we put the amount of water it's in on the bottom.
is oh, it is. It's 9, right? 9.
Yeah.
Yeah, me too. I don't like wait.
Let me go. Let's go from the honest. It's over.
Yeah, it's over.
Mr. Brown, why are you a hater?
Just comes natural, Cynthia.
What do you mean? For milliliters?
Cynthia, what's a hater?
You.
You just hate, yeah, basically.
Oh, okay.
You just hate on everything.
Well, you guys tell me you can't define something by just naming it, so I guess that's not really a good definition.
But I just told you.
You get 2 You know what? Fix that in that one. You gotta lock in tomorrow, right?
Oh.
We need to do tomorrow. We're gonna drop
Yeah.
some work plates.
Oh,
no,
that's no, we need to lock it.
One. And then 1 more.
No, that's the the formula mass, let's put that in gross now.
We have to find one mole of it, yeah, we do the formula under it, and then one mole, and then we find a mole of it, right? What's the formula mass?
So we have 231 grams of it.
Or-
Formula mass is 238.99, so we
What?
just 231 over 233. Because that's how many we have. See, it tells us we have 231 grams of it,
Not even close.
so we have less than
Nitrate.
1 mole of it.
Use the back of your
Oh.
periodic
For
table,
one
find
mole,
the
which is
compound.
So then, for that, we have to.
Yes, you have to.
Grams that one have.
In these problems, ladies and gentlemen, your volume has to be in liters for you to be able to work them.
16 times 6.
I will show you how, because I know
So
you
we
were
have
here yesterday.
185.
Yeah, so I'm gonna show you how to do these, but if you look over your notes from the, at least see how I did them in the notes.
So, because this is the formula mass
So
that we
this
solved
first
for.
one is like the
So we
first
take
problem,
what we already have, we know we have
There.
231 because it says it in.
okay? So we take it,
Divided
take the
by.
grams
Yeah,
of
but you
it,
did it the
convert it into
way,
moles.
we flipped it.
Then
Because
take
this
moles
is equal to
divided by the
44, so you
volume.
put it underneath it.
So that first one, we're gonna take grams of aluminum carbonate, we're gonna convert it into moles of aluminum carbonate, then we're gonna divide by the volume in liters, okay?
And then we have to
So on
find
the
the mole
next
last.
page, if you go to it,
The mole right number.
now we have a
Volume
volume and the molarity.
Mhm.
We
And
have
then.
a volume and molarity, we wanna find how many grams. Here we just found how many moles. So we would take this times formula mass over 1 mole to get to grams.
Well, that's milliliters, it has to be.
But it kind of shows you how to do it. The
So you
third
have
one
to
would be like
yeah.
at the bottom on the next page. Okay,
Which is just.
but I will show you how to do them, so you'll have a better idea too.
Wait, and then Mr. Brand, what do we put for the unit for this?
Multiply what? You multiply, anything outside of parentheses in a formula multiplies everything inside the
But like,
parentheses.
what's the unit called for this? Because we're solving for the molarity. It's just the capital. I think so.
Okay, so which one?
Oh, yeah, right here. That's what I'm doing.
Okay, so to find molarity, you need two things. You need how many moles there are there, and you need how many liters there
No
are.
second zero, just 0.6.
So, I'm not giving you moles, but I am giving you, okay, that can go to liters, but I'm not giving you moles, I'm giving you what?
What's the unit for mole?
You should be able to convert from grams of something into moles. We're gonna do that since you did it. So take the grams of that aluminum carbonate, convert it into moles, and divide it by the volume. Okay?
Grams. Yeah, what you said. 1.60.
Wait, is there thing M?
The
Is
unit.
When you're finding molarity, yes, you can use capital M.
Wait, so the molarity is already found in the second question.
Then, but I think they were talking about the first one. I assume, I don't know, but
Yes.
if they're finding a molarity, yes, you can use a capital M. And the second one, your final answer has to be in grams, yes. And in the third one, your final answer needs to be in milliliters.
So it's a positive 2 charge. And the formula mass is. We didn't find the full formula mass, we just have it present.
Well, I'm gonna have to find it because I got 224 and 16.
Did you get M? I mean, 2? For nitrate? So
No, because that one has a negative 1 charge, so it would just be
CN.
yeah.
Three minutes left, ladies and gentlemen.
Yeah.
3 minutes left. Sorry,
No.
I thought I was loud enough.
Oh wait, it's 3 it's 2 oxygen, 2 nitrogens, right?
Mhm.
Okay, yeah.
You don't seem to be getting very far.
Wait, zinc is.
Again.
Zinc is.
You're gonna struggle on a test if you don't practice now.
Oh yeah, I have it on here.
Shoot.
Plus 2 and nitrogen. I know.
Yep. Correct. Good. Now, the only thing I would tell you, you need to write the formula correctly for aluminum carbonate because it is not ALC. What you're doing there, Eden, is absolutely correct. Now you need to write a compound for aluminum carbonate.
Yeah. No, there's 2. There's 2.
The formula for it.
Is it just 2? Yeah, because it multiplies out.
Wait, okay, so Mr. Brand, can you come here real quick?
Certainly.
So for the second one, since we're trying to find how many grams of zinc nitrate we have, right?
Yep.
It gives us the molarity and it also gives us the volume.
Yep.
So can we, since it's, the volume's on the bottom, can we just, oh, we have to
You can flip.
Get it
Remember.
into moles.
yeah, we can put it on the top too.
Correct.
But
Yeah,
since
get it
it's,
into moles.
we can just write it down. I don't know how to say it out loud.
Wait, we have the liters, right? So we have 4 point, yeah, we have 0.4
We're solving for this, right?
5 liters.
Okay.
You have to do, what's the
Here's what I would
1
do.
liter?
Let me grab a sheet of
And
paper.
then morality, 2.11 mole, or M.
So,
Oh, I see.
this problem, you have a volume,
Gonna do
okay?
Oh.
I would take that times moles
0.4
over liters. This is molarity.
times 2.11.
So, in place of molarity, put 2.11 moles over liters.
Wait.
Volume times liters will get you,
Is it supposed to be liters or moles?
well, what's volume in what unit?
Well, this is
Liters times liters
So
will give
then-
you.
Liters of the mole.
wait, so
And
then
then
finding
the molarity. But,
are we finding a
wait,
liter?
so the 2.1,
No, we're
is
finding the
that,
That's this. That's 2.11 moles per liter.
Wait, so what is this again?
oh.
Wait, wait, is this
Oh,
right?
so
Remember
then
we
like that,
told
no,
you-
we did it like this. We'll explain it. We're gonna go over it. So.
6.3.
So when you see this,
Mhm.
what this means
Mhm.
is 1.60 moles over 1 liter.
I don't know if that's.
So
Is that
again,
liters?
So that's
Are we
different
finding
moles
liters
over
or
the
liters?
liter.
Correct.
So we can,
So you
So
can
this
use
was
that to
what?
convert between liters
moles?
and moles.
I don't know.
Should
That's
we
what
put
You
I
the-
could flip it if you were going from moles
I don't
to
know.
liters.
Should we put the 430, we should point that to liters.
Gotcha, yes, gotcha, yes.
Right?
Yeah. No, this on the bottom. So this equals our mole, yeah.
Okay, so here we go, ladies and gentlemen. Let's take a look at the very first one. Find the molarity of 231 grams of aluminum carbonate in 615 milliliters of water. Now, first thing, ladies and gentlemen, you have got to be able to write a compound for aluminum carbonate. To do so, aluminum is a +3. Carbonate on the back of your periodic table is a -2. So when you write the compound, you get Al2CO3 in parentheses with a 3 outside to balance off your charges. Questions? Now, first thing I need to do, to find molarity, it is equal to the number of moles divided by the number of liters. That is how we actually find it. So, for the number of liters, that is easy. I'm going to take 0.615 liters because I have converted this into liters and put it down on the bottom. To find the moles that go on top, I'm going to take the 231 grams times
1 mole of Al2CO33 divided by the formula mass, which works out to be 234.01, using the masses that I gave you on your periodic table. So if you calculated it with a calculator, this is the same number that you should have come up with. Can someone take 231 divided by 234.01 and tell me what we get? It's probably like 0.99 something. I'm sorry? Questions, ladies and gentlemen? Ask, please. Well, I hear people kind of, where do you get, and ask. Anyone have any questions?
If we leave it like that, is that okay?
No, it's not, because we need to finish this. I haven't finished this yet,
Oh, okay,
but
I thought we were done.
no. Do we have any questions where this came from? How about the volume? Go ahead, Farhan. Well, you take the mass of 2 aluminums, which is 26.97, the mass of 3 carbons, which is 12.01, and the mass of 9 oxygens, which are 16. You add this all up, and that gives us 234.01. That's unit 5. That's going from grams to moles or moles to grams. That's your formula mass. So when we take 0.987 divided by 0.65, we get probably about 6.6 something. No. 1.60. And now we can use a big M for molarity. And you're done. Questions? Now, here is the good news, ladies and gentlemen. On the actual test, well, there are going to be times where you may have to find molarity. How many moles were created? How much solution is it in? You may have to find molarity. I was going to tell you don't have to do this, but you actually will have to do this. Questions? Okay, number 2 then, ladies and gentlemen.
Wait, I do have a question.
Okay.
I'm just making sure my math is right. If I had 1.61, because I use more.
Again,
that's fine.
we're okay as long as you're in this 1.6 range. 1.59, 1.61. Could be a rounding error, things like that. I am okay with that. If you came up with 1.8, now we've got a problem because that's more than just rounding. You should be around this number.
Okay.
If you're a little bit higher, a little bit lower, I'm okay with that. But it's got to be around this number. Other questions? Thank you. Okay. How many grams of zinc nitrate are in 435 milliliters of 2.11 molar solution? Now, I have asked you, I implored you yesterday to think of this. 2.11 molar zinc nitrate. Zinc, yep, is a +2. Nitrate is a -1. So that's how I get the formula ZnNO3. 2, okay? I have implored you to think about this as this, 2.11 moles of zinc nitrate over 1 liter of solution, because now it looks like a conversion factor. When it looks like this really doesn't mean a whole lot to me. I can't see the units that are involved there. When I write it this way, now I can see what units I have. Now I can see that if I multiply this times liters, I will get what unit. And that's what I want here. So I am going to take my volume times the molarity. That will give me the moles of this. Now again, it doesn't want moles, it wants what? That's unit 5. That's going back to formula mass. That's going back to doing those things. But again, you'll never do formula mass if you can't write this formula. Okay? You still have all of your old notebooks. At the start of this trimester, we went through 4 days of naming compounds to review it with you. This is why you're using it again, ladies and gentlemen. This is how you are going to be using it. Okay? Questions? So, this was just the startup. Now I'm going to take this volume and I'm going to convert it into liters because it has to be in liters because of the liters on the bottom here. So I'm going to make that 0.435 liters. I'm going to take it times 2.11 moles of ZnNO3, zinc nitrate, with the 2 on it, over 1 liter. Liters and liters cancel. I will now have 0.91, somewhere around there.
918.
This is not your final answer. This is in the unit of moles. So now I'm going to take my 0.918 moles and I am going to convert it into grams using formula mass. The formula mass, 1 mole goes on the bottom. The formula mass for zinc nitrate, I got 175.39. So our final answer is going to be around 158.
What do you mean 175? We got 189.
65.3. Okay, sorry. You had the right one. I forgot to double my nitrogen. Sorry. So, yes, thank you, Cynthia.
189.9.
Thank you. $189.4. Thank you. So now you're looking at probably 170 some.
173.9.
But we're going to do sig figs. How many?
174.
3 sig figs. Questions?
Is concentration the same thing as molarity?
Yes. Questions? Okay, one more to go then, ladies and gentlemen. Now you're looking for milliliters of solution. Are needed to have 146 grams of calcium phosphate in 4.15 molar solution. Okay, so ladies and gentlemen, first thing I'm going to do is take my 146 grams and get it into what unit? Going to get it into moles. Okay, going to get it into moles. Why? Because then I'm going to use molarity to convert between moles and liters. But we'll show you how to do that in a minute. So 146 grams. Calcium phosphate is Ca3PO4 2. Okay. Now, I came up with a formula mass of 300.18 grams per 1 mole. Anybody else come up with that?
No.
I don't know if you're agreeing. What'd you come up with?
This was the last one, right?
Yep.
270.
So you had 3 calciums, 120.24. Did I
I
take?
did 2 calciums. You're right.
Okay.
Isn't it 3?
Yeah.
It's supposed to be 3. So yeah, if you accidentally messed up your formula and had a 2 here, remember calcium is a +2, phosphate is a -3. That's how I get the Ca3PO4 2. So we're okay with my mass here? All right, so what do we get from this? Gotta be just under a half.
0.486.
Okay. This, ladies and gentlemen, is 4.15 moles of Ca3PO4 2 over 1 liter, correct? I am going to flip this. I am going to invert it. Why? Because I have moles on the top here. I need moles on the bottom here. So I am going to flip this conversion factor over. And I am going to put 1 liter on the bottom, or on the top, moles on the bottom. Why? So that moles and moles will cancel out. Okay? Moles and moles will now cancel out. So now, ladies and gentlemen, and he didn't give you a cart?
Cart?
A cart? Whew, good luck.
Yo. What you mean a cart?
I mean a cart, something to carry it with, right here.
Oh.
Right there, right there. Something said.
Oops.
Here you go.
Yeah, you got
Got it? You got it? Okay, good luck.
This is motherfucking pause a bit. Okay, thank you.
Be careful going down the stairs, especially.
It's leaking.
It's just nice water. It won't kill anybody.
Does it taste different?
Nope. Some people say it has a little different flavor, but no. Nope. Nope. Okay. So 0.487 divided by 4.15. What do we get, ladies and gentlemen? 0. What? 0.117 what? Liters. Which we need to do what to?
Multiply by 1,000, sorry.
We need to convert it into milliliters. There is your final answer, ladies and gentlemen. 1.17 milliliters of solution. Questions?
No questions.
We're good?
Let's move on.
Okay, let's move on then. All right, open your EISN up, ladies and gentlemen, to slide number 12. You were. If you weren't wrong, you'd have been right. No, they're gone. I had 2. I'll have to go see if there's any in the back. Okay, so this is where you need to be, ladies and gentlemen, slide number 12.
Nothing.
Sorry, we're out.
I used to do that I think and say all the time.
Okay, ladies and gentlemen, mass to mass stoichiometry. Mass to mass means we are going to be starting with a mass and we are going to be asked to find a mass in the end.
Wow, I didn't know that.
So, if 40 grams of magnesium metal reacts with excess hydrochloric acid, how many grams of magnesium chloride will be produced? By the way, you did this reaction.
Oh, yeah.
You did. The other product besides the magnesium chloride would be what? Ooh, I guess we'll find out in a minute.
Wait, no.
Okay.
Wait, no.
So the first thing that we have to do for this, ladies and gentlemen, is we have to begin by writing a balanced chemical equation. So here we go, ladies and gentlemen. Let's write a balanced chemical equation. All right. So the reactants are the things that we begin with in a chemical reaction. One of them is magnesium metal. How do I write magnesium metal? With an M after it. Good. Plus hydrochloric acid. Don't everybody jump all at once. HCl aqueous. Very good. What kind of reaction is this setting up to be, ladies and gentlemen? Single replacement reaction. High school dance. You go to the dance with a date and somebody replaces you in the middle of the dance. So, Yuritsi goes to the dance with a boy. Alexis replaces her in the middle of the dance. Kicks her out. Says, nope, I'm now dating this person. That is a single replacement reaction. So the magnesium here is going to replace what part of the HCl? The H, which means we are going to get magnesium chloride formula. By the way, in a single replacement reaction, the one that is the compound will always be aqueous. And what else do we get?
Hydrogen.
Formula?
H.
Nope.
H2. H2.
Aqueous.
State?
Aqueous.
Nope.
Oh, G.
Gas.
Yeah. In the notes you have it as Mg metal plus 2 HClAq.
Hang on, we're not there yet. Sorry.
Oh, okay, cool.
You're ahead of me.
Sorry.
Because the first thing we have to do is write the equation.
Mm-hmm.
We have to write the equation. The second thing that we have to do now is balance it. So that's where you're ahead of me.
Oh.
For a reminder on how to balance, we list all of the things under the arrow. Magnesium, hydrogen, and chlorine. We count up how many are on each side, ladies and gentlemen. 1 magnesium over here, 1 over here. 1 hydrogen over here, 2 hydrogens over here. 1 chlorine over here, 2 chlorines over here. The reason that I do this under the arrow, ladies and gentlemen, is so that I can keep track of side to side how much of everything there is. I need to make sure that both sides have the same amount of each thing on them. Right now, this side has less hydrogen and chlorine than the other side does. So I'm going to solve that by putting a coefficient in front. The coefficient I'm going to put in front, what number times 1 will give me 2?
4. I'm kidding. Oh, shoot.
Sad part is I wasn't sure. Anyway, no.
You're not funny.
I know, but you weren't either, so we're even. Put a 2 in front there now. Now we update. There are now 2 hydrogens here, but 2 what as well? Chlorines. So now we have a balanced chemical equation, ladies and gentlemen. Now we can begin the next part of our problem, which is identifying what we're given. Yep. I know. Terrible. Terrible. Okay, good. So what we are given is 40.0 grams of this magnesium. What am I asked to find? So I'm looking for how many grams of this. Again, this is not a step that I'm requiring you to do, that I am grading. But you will find that this step helps keep you organized throughout the problem, especially the later ones when you have to find what we call a limiting reactant. So you're going to take the grams of magnesium and we are going to convert them into grams of magnesium chloride. We are going to take the grams of magnesium and we are going to figure out how many grams of magnesium chloride will be produced. Let me go through this. Step number 1, take what you're given and get it into moles. So 40.0 grams. How do I get it into moles?
Divide by formula mass.
1 mole over the formula mass, 24.305 grams. I'm not stopping there. That is the first step. I've taken what I've given and I've gotten it into moles. Questions? The next step. The next step right here. Let's go with green.
I thought you were What are you doing?
I want to eventually find the moles of magnesium chloride,
Okay.
right?
Oh, so are we gonna multiply?
So,
by the formulas?
The first thing that we do,
Mhm.
the first step is to take what you're given and get into moles.
Okay.
The second step, ladies and gentlemen, this one right here is we use what we call a molar ratio. The molar ratio is the moles of what we are going to over the moles of what we are in. So let me explain. What we are in is magnesium. So on the top, on the bottom goes 1 mole of magnesium. Why 1? Because there is no coefficient in front here, which means that is the number 1.
So even if there's 2, we just put 2 there
You'd put whatever number is in front,
of what we are.
you're going to put it down there.
So like if we were doing it for the hydrochloric acid,
We would put 2 HCl down here. Good. Good.
because it's the mole of what we are already in. And
You're
we have
in magnesium. So that's what goes down on the bottom.
Don't we have to find what the mole of magnesium is first?
We've done that here. This calculation, if I...
It's because you're doing it all together.
I understand. I'm showing you the easier way. Okay? This takes and gets us into moles of magnesium. This will get us out of moles of magnesium and into moles of something else, Sophia.
So when we're just doing where we're just like equaling it and then doing the next step, do we put the moles on the bottom of what we like?
No.
No.
If you were to do this like Cynthia wants to, like you're talking about, where you stop after this step, your answer is now moles of magnesium.
And then you multiply.
Then you're going to still multiply it by this step. I'm just doing it all at once. I'm not putting this into my calculator 3 or 4 times. Putting it in once.
Okay.
Once.
And then what are we going?
So what goes on top?
We're going to hydrogen, right?
No, we're not going to hydrogen. Where do you see that we're going to hydrogen in this problem?
We're going to the magnesium chloride.
How many moles?
1.
So on top goes 1 mole of MgCl2. Now, you may be sitting there going, why are you doing this if it's 1 to 1?
Because if there's a different number.
Because if it was the HCl, there'd be a 2 on the bottom. If we were going to HCl, there would be a 2 on the top. We can compare any 2 parts of this reaction to each other. Why? Because once we have a balanced equation, we have a molar ratio that relates any one part of this equation to any other. Okay? That is the advantage of balancing your equation. It gives you a molar ratio. Okay? And what it does is it simplifies our steps throughout. It unifies them. I don't care what number is in front here when I'm taking what I'm given and getting it into moles. I do what I've done all the time in Unit 5. Formula mass, 1 mole, take what you're given, get it into moles.
Oh, so we're getting it into moles of magnesium chloride because we're looking for how many grams of magnesium chloride we're going to be finding?
Thank you. Yes.
Oh.
This is our way of getting from one part of this reaction to another. Sophia.
So if we have like a 2 in front of the magnesium, do we still put that into the
Down here only.
mass?
Down here only. You
So
don't mess with this.
it's just what's on the periodic table.
This is what's on the periodic table. If there are coefficients in front up here, they will be taken care of in this step. Rather than us saying, well, since there's a 2 here, I got to put 2 moles on top and I got to double. No, don't do that.
We'll do
Don't do that. What?
So we cancel out anyways.
But it would also double the amount. Okay?
Yeah, I see.
Don't do that to yourself. Stay with the things we learned. How do we get from grams to moles? This is what we use. This step will take care of any coefficients that are written in your formula. Any. But what it also means is that for every one of these magnesiums, 1 mole of these magnesiums, how many HCl's would I need? 2 moles of it. How much magnesium chloride am I going to create? 1 mole of it. 1 mole of it. How much hydrogen gas am I going to create? 1 mole. All based on the coefficients in your balanced equation. Everything gets taken care of right here. Questions?
Not really.
What's the last thing we need to do to this problem?
Convert it into gram.
Convert what?
The magnesium chloride.
So guess what? One more step. But how do we convert moles into grams? We do formula mass. So we are going to do formula mass again, ladies and gentlemen. But this time it's the formula mass of what?
Magnesium chloride.
The magnesium chloride. Which means I'm going to put 1 mole of magnesium chloride on the bottom. Why? So they cancel out. And now magnesium chloride, ladies and gentlemen, 2 times 35.45 plus 40.08, that is 110.98. You don't believe me? Go ahead and check my math.
On here you have 95.21.
Geez, check my math. Did I give the wrong mass of magnesium? Oh, I did. My bad. I used the mass of magnesium here. Sorry. Thank you. Don't check my math. It's terrible today. 24.305, which is 95 what was it? 9205. Does that sound right?
Yeah.
I'm sorry. Please forgive me.
Okay. If you did this right, unit cancels unit. Unit cancels unit. Unit cancels unit. And by the way, this was moles of magnesium. You are left with grams of magnesium chloride. So now, 40 divided by 24.305 times 1, leave it, times 95.205. One time, one calculation, you are done. So what do we get?
I got 157.
Anybody else?
157.
Cool.
I'm good
Cool,
with
got it.
that.
I trust it. Oh, it's Sophia's math, so maybe I shouldn't. Just kidding. She can do math.
You will do the same 3 steps on every problem we give you in this unit.
Now do it the other way. I don't know how to do it this
What do you mean the other
way?
way?
All separately and explain it like that.
No, do it yourself.
I don't get it.
Then do this and get an answer. Take that answer times 1. Then take that answer times 95.205.
That's so much easier.
Really? It's easier to do that 3 times than just punch this into your calculator once. Then do it that way. I have no problem with that.
My brain just works
Do it
better
that
that way.
But here's the thing. On a test, this is 2 points. Well, let's begin at the top. 1, 2, 3, 4, 5 points. 6 if we count the symbols. 1 for each formula that is correct. 1 for balancing it correctly. 1 for putting the correct states. 6 points. 7, 8, 9, 10, 11, 12, 13. There are 13 points in this one problem. That's okay, because on your test, there'll be about 20 to 30 points on a problem.
Why?
Because you're only going to have 4 problems on your test.
Oh,
Questions?
that's something.
Hey, wait,
Questions?
No, practice time?
Heck no.
What do you mean?
I mean, heck no.
Like, why?
Why?
Yeah,
You aren't ready to practice yet. You barely got this down.
I got it down.
Really?
Are you being a hater?
Yes, very much so.
Wait, do the next one and then do it separately.
Determine the mass of copper needed to react completely with a solution containing 12 grams of silver nitrate. All right, you got it down, KP. What does our equation look like?
Determine the mass of copper needed to react completely with a solution containing copper Cu.
Okay.
What's the thing? What's copper's charge?
We don't know.
I don't know why you would need it.
Never mind, we don't need it. Ag2NO3.
Well, it's just Ag and silver. Yeah, it's just Ag and O3.
Now, I take it back, KP.
What?
You would need to know the charge of copper,
Oh, okay.
not at the start, but to write the compound at the end.
But you didn't give it to us, so.
You're right. So in a problem, I normally will do this.
You forgot the other parentheses.
Sorry. Okay, I'll go back and I'll put it in there. I typed it too fast. It didn't catch it. That's what happened. Okay. So I would have to tell you something like this. Copper is a +2 charge in the compound. So here you go, ladies and gentlemen. Copper, silver nitrate, AgNO3, silver a +1, nitrate a -1. The copper is going to replace the silver. Why? Because they are both what?
Metals.
They are both metals. They are both at the start of the compound. Copper will replace silver. Thus meaning silver's got to leave its off on its own. The product is copper nitrate. Copper is a +2. Nitrate's still a -1, so it's got to be aqueous. Now you need to balance it. Because there are 2 nitrate groups here, I need 2 of them on this side, so I put a 2 in front here. 2 in front here means there's also 2 silvers, so I put that there.
So is it balanced already?
Now it is, now that you have those 2s in there. When it was originally written, no.
Why'd you skip that? Okay, whatever.
Well, do you want me to go through and show you how to balance it again?
No.
Yes?
No.
Okay. Well, there are people behind you who are going yes, so is that okay?
Wait, why are you asking? You're saying determine the mass.
Hold
but you
on.
have a question mark for grams.
Well, because what is mass in? What unit?
Oh yeah, grams.
Grams.
Girl.
So originally, ladies and gentlemen, again, when you were doing this one, originally, copper, silver, and by the way, I'm going to leave the nitrate group together here. Because if I leave it together, if I pull it apart, it doesn't matter. It's the same on both sides. So it's an NO3 group over here. It's an NO3 group over here. 1 and 2. Originally, there was 1 and 1. And originally, there was 1 and 1. So I put a 2 in front here. To get to 2 of these, I then had to have 2 silvers as well. When I put a 2 in front here, that finished balancing everything out. Questions? Better? Okay. So that is what I am looking for, the grams of copper metal. I'm given 12 grams of the silver nitrate. So what's the first step? For what? No, you can't find moles of copper. You don't know how many grams of copper there are. What do we begin with?
The moles of the silver nitrate.
Well, we don't have moles.
Will you find the moles?
Thank you. Take what you're given, the 12 grams, and turn it into moles. 1 mole over the formula mass for silver nitrate. What's our next step?
The mole ratio.
The molar ratio. Molar ratio says 1 mole of copper to 2 moles of silver nitrate. Why 2? Because of the number in front. Here I'm accounting for these coefficients in this one step. I don't have to worry about it in here. Okay? Take what you're given, get it into moles. Ratio step to get from what you're in or given to what you want to find. What's the next step? First step, take what you're given, get it into moles.
Oh, yeah,
I don't think I
grams,
stated this very clearly on the last problem. First step, take what you're given, get it into moles. Second step, molar ratio. Third step, take your moles, put them into your final unit. Put them into your final unit. Our final unit is what?
Grams.
Of copper. So how do I get from moles of copper into grams?
1 mole over mass of copper.
Not 1 mole over.
The mass over.
Formula mass over 1 mole.
Wait,
Formula mass over 1 mole.
Mass of what? Copper?
Yes, because you're now in copper. Yes. Go.
So this equation works for all of them, like no matter what we're trying to find and what we're given in that equation.
Yes.
So even if you give us like one on the right side and we're looking for one on the left.
Yes.
Okay.
Yes.
Can you said like the first step is taking what you have and put it into moles. What did you say the second step was?
Molar ratio. Molar ratio. And then finally, ladies and gentlemen, report out what you're given in the unit they want.
So then the third step would be go to the unit.
Go to your final unit. Go to your final. You're going to be in moles. Now take it into your final unit. Questions?
What's the answer?
2.24452 grams of copper. Which, how many sig figs? 2.44 grams of copper.
What is that? Oh, 6.
Now, caution with your calculator.
When you do that.
When I do this, I take this 12 times all the numbers that are on top, and then I divide by all of the numbers on the bottom. How many numbers on the bottom do I have to worry about here? And if I have 2 numbers on the bottom, what do I have to do to those 2 numbers? Put them in parentheses. If you don't put them in parentheses, you will come up with the wrong answer. Okay? So, 12 times 63.55 divided by parenthesis 169.88 times 2. Close your parentheses. That is the number that you will come up with every single time. Questions? Now, we won't get into it today. What would be this problem? What if instead of asking you for grams of this, I asked you about the hydrogen gas? Would I ask you for how many grams of hydrogen gas there were? What would I probably ask you? What?
Liters?
Okay, so what are we gonna do?
Liters?
How?
Well, we can put grams and some moles and then
Probably not gonna be at STP.
Oh.
But we taught you last unit, PV equals nRT. So if I give you a pressure and a temperature, you could take your number of moles of hydrogen gas that you would create here. You could figure out what volume it would occupy. You could figure out what volume it would occupy. It's not, you did it in your lab last unit.
Yeah, that was last unit.
I know, it's a shame that I'm making you remember that stuff.
I know.
So this would be so much easier if everything you just learned it at the time and never had to use it again, wouldn't it? Yeah, I agree.
Wait, what was the last step? The grams of
On this one or on the one we were kind of talking about? Well, right now they're mass to mass. So that's why I'm giving you a mass and I'm asking you to find a mass. Now there are two other ways I can give you information instead of mass. I could give you the volume of a gas, its pressure and its temperature. You could then find N. If I give you pressure, temperature, volume, you can use PV equals nRT to find number of moles.
and then we would do that exact same step.
You would take what you're given, you'd get it into moles.
But if we're given moles, we just skip that.
You won't be given moles. I'm not going to do that. I'm not going to give you moles.
No, when you said the PVNNC, it's going to give us it in.
So once you get it into moles, then we do the second step, molar ratio. Then you come out in whatever unit you want. We're getting a bit ahead of ourselves. I should slow down. Okay? So, calculate the mass of silver phosphate produced if 30.0 grams of silver acetate reacts with excess sodium phosphate. Now we got a reaction, ladies and gentlemen. Now we got a reaction. Okay, so if silver phosphate is produced, ladies and gentlemen, where does it go in our reaction?
The right side.
After the arrow. After the arrow. So somebody tell me what the formula for silver phosphate is.
AG3,
AG what?
3,
Good. Silver is a +1. Phosphate is a -3. So Ag3PO4. Okay? All right. Well, go ahead.
How do we know it's on this side?
Because it said it is produced. It's made. It's a product.
And silver acetate is on the other side.
Okay, how do we write silver acetate?
C2H3O2.
Are you sure about that?
I don't know what you have up there.
Silver +1, acetate -1. Yep, that formula is correct. Sodium phosphate. Formula.
What?
Na3PO4.
Perfect. I hope you have these handy, ladies and gentlemen. Because now you need to find silver acetate. And you need to tell me, ooh, don't look at it, never mind. We'll get to that later. If we look at it, it's going to mess up this problem. Okay? What would be the other product here?
NaC2H3O2.
Perfect. 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 I got to find a better one. Don't look at your sheet yet. We'll get to that later.
Is it wrong?
It is, because this is a precipitate, so this reaction wouldn't happen.
Sodium phosphate? Yeah. No, it's sodium acetate.
Sodium acetate. Why? The sodium and the silver did what in this reaction? Switch spots. This was the double date at the dance where the people switch partners by the end of the dance. Okay? Now, Ag, Na. I'm going to do a little trick here, ladies and gentlemen, for balancing. I'm going to leave this together, and I'm going to leave this together. Why? Because they appear the same on both sides. Exactly the same. So I'm going to leave them together. All right. How many silver over here to begin with, ladies and gentlemen? How many? Thank you. Sorry, I don't speak German. I didn't know what you said. How many NAs over here? 3. Now be careful. How many C2H3O2 groups? 1. There's no parentheses, so there's only 1. How many PO4 groups? 1. Let's go to the other side. How many AGs over here? Okay. How many NAs over here? 1. How many C2H3O2 groups? 1. How many PO4 groups? 1. What needs to get balanced? Okay, so let's start with the AG. Which side needs more? So what number do you want to put in front here? That makes that 3, correct?
You messed up on that thing.
What else changed?
The acetate, that one.
Okay. All right. So what still needs to be balanced? Okay. So here's Na on the product side. What number do you want in front? Now, understand, the order that you write these in does not matter as long as they're on the correct side. So if these two are reversed on this side, it means nothing. They're still both products. If these two are reversed on this side, it doesn't harm anything. It just means those are the two reactants. Questions? Okay. All right. So what are we given? What are we given in this problem? All right, so we're given 30 grams of this stuff. What are we looking for? We're looking for how many grams of this. Okay, now let's see if I did this correct in your notes. So there's your formulas, correct? Okay, 30 grams of that. Looking for that. So what is the first thing that we're going to do?
Take 30 grams of silver acetate and put it into mold.
Take what you're given.
But you gotta find the formula mass of silver acetate first, right?
Yes.
You gave it to us.
Yes, but I'm just saying, the step that we go through is to take what you're given and get it into moles. Every one of these we've had to find this formula mass. Believe me, you will have to find it. I'm not going to give it to you all the time. Okay? So, 1 silver, 2 carbon, 3 hydrogen, 2 oxygen. You add it all up, you get 166.92. Next step. Now what?
3 moles of silver acetate, 1 mole of Ag3PO.
So which goes where? Well, it's important to know.
The one that we're looking for goes on the top, I think.
Correct.
So they want to cancel out.
So we're looking for the silver phosphate. So
So that's
1.
the top.
So 1 mole of silver phosphate over 3 moles of silver acetate. Again, this kind of helps. Here's the one that we're in. Here's the one that we're looking for. By the way, you don't want to write out all of this unit, the compound here. I'm not going to mark it off. I'm not going to mark it wrong. But if you then get this mixed up because you don't know which one you were in, well, that's your fault.
What is this stuff called?
Okay?
The molar ratio.
Take what you're given, get it into moles, use the molar ratio. Final step. get into what unit?
Grams.
How?
Moles.
Formula mass of what?
AgPO.
Ag3PO4. So now you've got to find a different formula mass. 3 silvers, 1 phosphorus, 4 oxygens, 418.58. Way different from here, correct? Why? Way different compounds. Way different compounds. Grams, cancel grams. Moles of AgC2H3, cancel moles of AgC2H3O2. Moles of AgPO4, cancel with moles of Ag3PO4. We're left with grams. There's your final answer, ladies and gentlemen. 25.0766 grams. Which in 3 sig figs becomes 25.1. Questions? Good. Tomorrow you're going to get plenty of practice time. Now, you will not have a quiz on Friday. It'll be next week, Monday.
Oh.
Good. I love that enthusiasm. That is awesome. And it will be molarity problems and possibly one mass-to-mass problem. We'll see. We'll see. By the way, the days of the multiple choice quizzes that we took in the first try, long gone.
So no more Fridays.
What? No,
When do we have multiple choice?
we had some in the early part of the
I
year.
don't remember that.
We had some in the early part of the year.
That's so proud.
By the way, if you look at problem number 10 on the packet I gave you, that's an example of what your test is going to be like. 4 questions like that. You bet.
Number 10 of the first.
Of the packet.
Just
The
4
worksheet.
questions?
Of the last page. I'm sorry, the last page. Go to the very last page. I don't know what packet that is.
Bright yellow.
Yep, the one on the bottom.
Is burned with, yeah, you know how many questions it could be? It's like this. Yeah, but do you know how much work we have to learn to see that?
You need one or no?
Sorry, for real. I try not to get
Anything
excited.
else?
It looks like a banana boat, so. Okay, understand.
I won't break it.
Good.
I'd hate to have to kill you.
For wearing my jacket?
What?
Was that a threat?
You want another one just in case you lose the other one that I gave you? What's it?
I was shocked.
I'm here in the mornings, but not tomorrow morning, or not Friday morning.
Oh my
I'm here
gosh.
after school, but not Friday after school. What? Oh, sorry.
Yeah, but that's like the best one, you know, like when it's just like out of the blue.
I just don't like how it's funny the same as
Wait, what's his name? Jay?
yeah.